Okay, the diagram below shows a stationary cart on a frictionless surface. Two unequal opposing forces are about to be applied to the cart. The photo shows to the left, it's being pulled with a force of 70 newtons, and to the right, it's being pulled with 360 newtons. If the unequal opposing forces are applied to the cart at the same time, what will occur? So, I'm going to box my question up. And let's underline keywords. I see that the cart is stationary, which means it's not moving. It's staying still. Two unequal opposing forces are about to be applied on it. What we need to know about forces is that when something is unequal and opposing, it is going to be unbalanced, which makes sense because if I'm pulling on one side harder than I'm pulling on the other, that object is going to move, which we know unbalanced forces will cause a change in motion, either speed or direction. So will it remain stationary? Will it remain staying still? No, because there's going to be an unbalanced, unequal opposing force applied to it. Will it alternate between moving left or right? No, because this is the other thing we need to know, that objects always move. Objects move in the direction of the stronger force. Okay, so if somebody's pulling one side with more force than the other, the object is going to move in the direction of the stronger force. So when I look at my picture, I can clearly see that the stronger force is being pulled to the right. So this cart is going to get pulled to the right, which is the answer A. It's not going to go back and forth because it's being pulled stronger to the right. Number 2, a probe traveling through outer space is moving at a constant velocity. Which statement applies to the motion of this probe? We're going to box our question. Underline and talk about important words. It says it's moving at a constant velocity. Okay? Constant means no change. Velocity means speed plus direction. So there is no change in the probe's speed or direction. If there is no change in its speed or direction, can there be an unbalanced force? No, because unbalanced force means change in speed or direction. So A is not right. Causing it to accelerate. Accelerate means change in, accelerate means change in velocity. So that's another hint that A is wrong. Because if it would cause it to accelerate, no. It says there's no change in speed or direction. B says the probe will undergo constant acceleration until a force acts on it. Again, it says acceleration. And accelerate means we're going to change in speed or direction. No, it says it's moving at a constant velocity. C says the probe will continue in its current path until an unbalanced force acts on it. Continuing in its current path is what it's going to do right now because it's got balanced forces acting on it. There is no change in speed or direction. It says until an unbalanced force acts on it. So that sounds good. Let's look at D. The force that makes the probe move through space is equal to its mass divided by its velocity. So this is getting technical into some things that we will learn past 6th grade, but mass divided by velocity is not equal to force. It is actually mass divided by acceleration. That is equal to force. So that confirms that C is my correct answer. Number 3, a rock is resting at the top of a hill. The rock suddenly begins moving down the side of the hill. Why did the rock begin to move? So if something's going to start moving, it's going to have to be because there's an unbalanced force. Because if it's beginning to move, that means that there is a change in motion. A says an unbalanced force acted on the rock and caused it to move. Well, that sounds like a perfect answer. B says a sudden change in gravitational force caused the rock to begin to move. This is not true because we don't have sudden changes in gravitational force. Gravity is a constant force on our Earth. So that is not true. C, balanced forces caused the rock to move and then gravity kept moving it. Do balanced forces cause things to change in motion? No, only unbalanced forces do. D, an upward force balanced the gravitational force, so the rock began to move. Again, balanced, began to move, those things do not go together. So that confirms that my answer is A. Number 4, the following picture shows forces acting on a sneaker. Suppose the sneaker is moving toward the spring scale. In which direction is the sum of all of the forces, aka the net force, acting? In what direction is it going to act? This just tells me what is the direction of movement. And this is really simple if you know two things. One, you got to know for your left from your right. And two, you got to know what a spring scale is because it tells me the direction of movement. It tells me it's moving toward the spring scale. What is a spring scale? If I look at this picture, actually, do we really need to know what a spring scale is? I know a spring scale is not a sneaker. I know a spring scale is not a hand. I know a spring scale is not a table. The only thing left in this picture is this right here. This is my spring scale. So if it's moving toward the spring scale, it is moving in this direction, which is to the right. D is the correct answer for this question. And number 5, the diagram shows 2 dogs pulling on a rope with constant but unequal force. Unequal means unbalanced, means there's going to be a change in motion. In which compass direction will both dogs most likely move? So in which compass direction? Here's a compass right here. We don't even have to remember never eat soggy waffles for this one. Looking at the dogs and the strengths they're pulling with, it says we're pulling with a strength of 200 newtons to the right and 175 newtons to the left. Now, we reviewed before, objects move in the direction of the stronger force. So I'm not going to write that down again. I'm just going to know that the stronger force means more newtons. So this dog is the winner. Both dogs are going to get pulled to the right, which, if I look at this compass, correlates with east. Because this was a shorter video, I just want to quickly review calculating net force. So for to calculate the net force of this problem, I would take my forces 200 to the right and 175 to the left, and I would know that I'm supposed to subtract them because they are moving in opposite directions. Right and left do not work together, so I subtract them. 200 minus 175 is 25. You need to have that arrow above it, okay? So the arrow above it is going to match the stronger force. So for this problem, it'll be 25 to the right. And I want to do the same thing with this problem here. Let's say that the force of gravity is 80, that the normal force of the table is 80, that the friction pushing the sneaker to the left is 10, and we know that it's moving to the right, which means that the right is going to have to be a stronger force than the left. So any number bigger than 10 will work. Let's go with 20. For this problem, you only calculate net force of opposite forces. So I will not take all of these numbers and add them together or try to subtract them in some way. Instead, I will just take my opposites. I will just take the down 80 force and the up 80 force and the left 10, right 20. Those are the only 4 forces I will worry about. When I worry about these forces, I will just look at them with their opposite. So if I were to calculate this up-down force, net force, 80 down, 80 up, those are opposites, so I would subtract them, equals 0. So that tells me that it is not going to move up or down because those are balanced forces. When the net force is 0, the forces are balanced. Down here, always subtract the big number minus the small number when they go in opposite directions. 20 minus 10 is 10, and the stronger force is going to the right. So that tells me that it is unbalanced. Horizontally, it's going to pull to the right because that is the direction of the stronger force.